Very nice to meet you all. I see about 74 people are on this right now. So I'm a little nervous what to talk about the future of data analytics career. Okay. But let me first ask you a question. How many of us are in this room already having some part of a data analytics career? So if you are in data analytics already, right? Any part of it, maybe it's data engineering, analytics, ML, whatever it is. Type yes on chat. If you are not in that field, type no. So let us really talk about the basics here, right? A lot, because most of us are not in a data analytics career at this point in time. And, if we, at the same time, some of us are. So we will definitely have some time for question and answers. So we could take some more advanced questions when we have the Q&A, right? But when I'm covering what it is, let me just go to the basics. So what is data analytics? Can anybody say what is data analytics? You are here to attend a session on data analytics at least. And those who are in the data analytics career, please don't say this. Those who are not yet, right?
Recognize the raw data, make some meaningful that things, or analyze the data.
Raw data, you convert that into meaningful analysis, something out of that, right? That's what you said. Thank you, Shikha. Anybody else? It's okay. You can say completely wrong answers. No one will judge you. What is data analytics? Why are you here, right? You would know what is data analytics, or you don't know what is data analytics, so you want to explore what is data analytics at the core, and that's why you're here. So collecting data, then organizing it, and then making predictions out of it. I think you're all getting a sense of that, right? So everyone is saying the same thing. Anyone else? One more. Let's take one more definition.
Yeah, data analytics can shape business process and to improve decision making.
Data processes and, sorry, exactly what did you say?
To improve our decision making.
Right.
And yeah.
Absolutely.
The faster of business growth.
That's correct. So in the absence of data, if you have to make any decision, right? So for example, you don't have Google Maps. You are stuck in an unknown city and you are on an unknown road. You have to go to your uncle's house and no one to ask. You will probably try to recollect when you went last time, or you might just start walking in a direction. Let me see if I can reach and I'll find some familiar roads. But all of that problem is solved when you have either people to help you, or if you have Google Maps that will exactly tell you where to go. So people are providing you that data, or Google Maps is providing you that data. This is the direction, right? So once you have the data and you process it in your head, somebody might say that, okay, we don't know your uncle's house, but we know this mall is in that direction. Now you're doing in your head a little bit of analysis. Yes, from the mall, it's the third left. So I know my uncle's house. So data, you're processing in your head, analyzing it, and then you are getting your insights required for your decision making. Your output is you want to reach your uncle's house. You have to make a decision, left turn or right turn. So this is a very practical example, but convert that into a real life business situation. You have tremendous amount of data coming out there. Unless you analyze that data, you will not be able to make meaningful decisions which will help you propel your business forward. You can't just go by, I think sales are increasing in the Mumbai region, looks like. So let's start selling more of this product there. No, look at the data. Is it really happening? It's as simple as that, right? So that analysis is what you call data analytics. So the data analytics is a process of gathering the data and organizing it and creating meaningful insights out of it so that you can have data-driven decisions. Okay. Now, data is a very interesting term. So I'll give you do you have any idea how much data is getting created every day? So let me tell you this. 10 years back, in 2013, in a year, there were 9 zettabytes of data that was getting generated in the whole world. 10 years back, just 10 years back. Okay. And it would be like much, much lower if I rewind another 10 years in 2003. This I'm talking about 2013, 9 zettabytes. Now, zettabyte, anybody know how many zeros after a 1 to get a zettabyte? You know about a million, right? 1 and 6 zeros. Billion. So equivalent is megabyte and gigabyte, the number of data storage points, right? Now, how many such data points are there in a zettabyte? 10 to the power 21. So 1 and 21 zeros. Unimaginably large number. 9 zettabytes of data were getting generated in the world 10 years back. Fast forward 2013 plus 5, 2018. This 9 became 24. Of course, world was having more social media, a lot of things, and there is a data explosion already happening in those 5 years, 9 to 24. Now hold your breath. Between 2018 and then you had 2019, 20, then the pandemic years, and now we are here, 2023, last 5 years. This 9 has gone to what number? Anybody, any guess? You can type on chat if you have a guess. So 9 has gone to 24 in 2018, and 24 has gone to what now? Number of zettabytes of data getting generated in a year. 90, somebody has said that. Raghav, anybody else? Any guess? Any other guess? 50, 80, nice auction. 100. Okay, 120 zettabytes of data. Somebody has Googled also or knows the number? Mujamil? So 120 zettabytes of data are getting generated as of today in 2023. 5 times in the last 5 years. We are generating data everywhere. When you are surfing on Facebook, every click that you make is creating data on your user behavior. When you're purchasing something on Amazon, that's creating data. When you're asking ChatGPT a question, data is getting generated. Your question itself is creating data, and ChatGPT is creating fresh data out of that as an answer. So truly a data explosion is happening. This is going to continue like this, and there is an estimate of the global data analytics market. It is estimated to be $41 billion in 2022, as of last year, $41 billion. This is expected to grow at 30% per year. And in my opinion, these are all estimates that people are giving, but it's going to be even more. 30% per year, the data analytics industry, the industry that is involved in, and that's where, when it comes to career, this is a very interesting number for us. 41 billion today is going to expand to 346 billion by 2030 in another 7 years. That's almost more than 8 times. That is driven by one, the explosion in data, as I just explained. Second, for us to really live effectively in this world, we need to actually make sense of all this growing data. Competition is growing. Companies want to know what are customers really preferring. So they need to understand where are people clicking, what kind of things are people buying. Traffic, electricity consumption. You look anywhere, like you're talking about connected devices. You can have a single central point from where you can control your fan, your AC, your fridge. Now it's all expensive and an experimental stage, but 10 years from now, it will become more of a magical world where we control all this. Now that's all data. To drive the world into a particular direction, you need to analyze all of that data. And that's where data analytics really becomes critical. So it's a huge opportunity, more than ever in history at this point in time. And I mean, the best example of where this is going is ChatGPT itself. How many of us have used ChatGPT at least once? So ChatGPT, so check out ChatGPT. This is a new technology that has come up where all you need to do is Google ChatGPT, and then you will have an interface. You have to register there, and then you can start asking questions. So when you ask Google a question, that was the best standard that we had so far. You will get lots of answers, and you need to figure out what is the right answer you want. But when you ask ChatGPT, you ask a question, it will give you the answer specifically to your context. Now you can ask another question on top of that without saying anything about the previous question. It will remember the previous question, contextualize it, and give you the second answer. Then third, then fourth. This is called generative AI. Artificial intelligence, which I'll talk more about that later, which is kind of the most advanced form of analytics, is now getting into such a level where computer can generate fresh content. So Google actually by end of this year in Google Pictures, everyone takes pictures and stores in Google. Now generative AI is actually coming with a new feature where, let us say you have taken a picture of a person and the person is like cut from here. Now you didn't click it properly. So you don't like that photo and you lost an opportunity to click a nice photo. Using generative AI, computer will generate the remaining parts of the face based on all the features and you will have the full picture out there. So this is magic, right? Like Harry Potter. So that is where the world is now going. So, so all of this is advanced forms of data analytics. And there are people working behind the scenes day and night, creating these technologies. And that is the career opportunity you have if you can drive it towards that. So with that introduction of the huge opportunity and the amazing pace at which, right? So it's not about text, it's about images, it's about voice. So many things, right? People can generate, my voice can be regenerated. So things I haven't said, this is actually dangerous also, because people can fake my voice and create things. So there has to be more regulations, law, all of that has to come. That's another field for somebody to explore career. Data security, ethics in data. How can you bring more regulation? Very interesting research work is going on in that field also, because criminals will also have access to all these technologies. So they can spoof somebody. They can create fake videos and fake images of people, fake live telecast, right? So I'm sitting here and talking, I'm really there, but 10 years from now, you really need to believe whether I'm there or not, right? It could be fake. So how do you control all of that and bring a bit of regulation around it? So it's extremely interesting field. Now, from there, now let's come back to the ground and start exploring what are the 5-6 stages of this this data analytics process. First is, of course, gathering the data. You have data from various sources. Sometimes you can conduct a survey. The survey will get you a lot of data. You ask 10,000 people questions, they will give you tremendous amount of data on. Now I have done survey. I understood, right? How many of you are in data analytics career and how many of you are not? That's a simple data generation. I just generated data within this room. So similarly, you can conduct large surveys. You can when you are going to a website, you accept cookies. You experience that, right? When you're accepting a cookie, your click movements are measured by somebody when you're accepting that cookie. So everything that you do online, somebody is actually watching over. They may not be really sitting and watching like this, but the data is getting captured somewhere. So all of that data, that's again a way of gathering data. You go to a manufacturing plant, the processes, how many products are getting generated, quality rejections, all of that again is a data. Your sales data, that's also data. So the data that you're creating, we are writing an article, unstructured. So there are two types of data. One is structured data, which is your numbers, right? In a table, your sales data, that's in numbers, a table. Second is unstructured data. There's no structure to it. I'm writing an article. There are lots of words in it. I wrote 100 articles. Now you can analyze to see what's the common theme I'm talking about in all these 100 articles. Now you don't have numbers to really compare. You have to look at all those words and have an intelligent system to really make sense of that unstructured data. That's called unstructured data. There's no structure to it. Could be any words, anything, article, photographs. For example, there are 50 photographs and you have to find out which photograph is not taken in that place. Computer can figure that out, right? That is unstructured data. Computer is able to understand how these pictures are, and then from that, identify the characteristics and separate out category A from category B. You can create two categories, things which were taken in this room, things which were not taken in this room, photographs. So that's unstructured data. So you can all of this data. You are clicking a photograph, that's also data. You feed it somewhere. Google tells you 5 years back you were here, remember this day. So that is because it is stored and it's analyzing and it's actually telling you coming back, or the place you are in right now, there are some memories associated with this over the years. It's able to kind of connect all of that. Gathering data is number one, but second part of this is cleaning that data. Not all the data is easily usable. Just look at it this way, right? You have a lot of systems, for example, sales data. Let us say you have 1,000 sales representatives going around the country, selling things. They are marking their sales on ledgers, and somebody is typing that. It's bound to have lots of errors. Not everything is like completely digitized and right. So it definitely bound to have errors. Now, if you are giving that erroneous data, the data file with lot of errors, or multiple data files with lots and lots of errors to a system to analyze, or you are a data analytics person sitting and trying to analyze data, what will you get? Good insights or bad insights? Bad insights, isn't it? Because junk in, junk out. You give junk to the system, it will only give you junk output. So first and foremost thing is to clean the data. This is a huge space, data cleaning. Now, same data can be in 2-3 different systems stored. Some part of it is in one system. Some part of it is in another system. I'll give you an example. There is sales data. So let me just call out some names here. I have sold some things to Rohini, some to Shubham, some to Sarthak, some to Rishabh. Now, I have that data, who has bought what. I have another file which says the career, what profession are you in, or maybe some other data, or which city are you living, or are you living in a city or in a village. Mapping these two data and mapping what products you bought, I can make a lot of assumptions and a lot of analysis on who is going to buy what kind of products. It's not in one place. One place only says names, Shubham, Sarthak, Rohini, like that. Second one says Shubham is doing XYZ, Rohini is doing something else, Sarthak is doing something else. Mapping the two, people who are into, let us say, involved in, I'm just making it up, painting profession, right? They are an artist. They prefer this kind of things. Maybe I'm a salesperson for watercolor paints. Some of you are students. They like certain things. So if I know that the professional painters are using a particular kind of paint, I can actually start selling more of that to those people. So these are coming from two different tables. One is your customer data. One is your sales transaction data. Bringing them together into a common view, unifying it so that there's no confusion who's what. All of that is important for before you even start analyzing your data. So this whole space is called data management. And when you are talking about really large amounts of data, for example, the data on thousands of news articles, and you're trying to figure out whether there is a violent theme coming up in that particular area based on what people are posting on social media. That is called, when the data is very large, that's called large volume. With different types of data, large amount of variety of data, and they're coming very fast, because in social media, you are clicking, you are liking, you are commenting, lots of the velocity, the speed of that data is also very high. So when these 3 V's, what are the 3 V's? Volume, variety.
Velocity.
Sorry, volume. Velocity. Yes, volume, variety, and velocity. If these 3 things are all very high volume of data, high velocity of data, meaning quickly data is coming, and different varieties of data, large varieties of data, that's called big data. To analyze big data, you cannot use just a spreadsheet or an Excel file. You will need to write code. You need to figure out how to one, clean this data, figure out what is really going on in that data. Are these data all talking to each other? And before you can even analyze, you need to all bring it onto a common platform. So that is called data engineering. When you are working with such big data, there is a whole discipline called data engineering that has evolved over the years. 10 or 15 years back, if you ask me somebody, what do you work on? Oh, I am in big data engineering. People will think that, yeah, I've heard of it somewhere, but not very common. Today, it's a mainstream profession. So you're not analyzing data, but just getting the data together. That itself is an exciting space with a huge amount of career opportunity, because so much of data is getting generated. Somebody has to clean, bring it together, and make sense of that. Now, the other thing is, right, one related concept, again, I don't want to get into a lot of depth here, but I want to give a bird's eye view to all of you, given your background, so that everyone understands and takes something out of it. One word I want to say here is cloud. When I was a child, if somebody said a cloud, right, I would have looked up in the sky. Of course, in Delhi and many parts of India now, when we say cloud, only one thing comes to our mind, because there's too much of rain happening in many parts, right? But cloud has taken a completely different meaning now. So earlier, our data used to be in your computer, and when you want to mail that to somebody, you will put it in a spreadsheet, mail it to somebody over an email, or you can transfer using chat. So today, you can actually store all of this data in a common place, not in your computer, but somewhere else. All of us are using cloud every day. What is happening? What do you think is happening when you are having a WhatsApp chat? The data is not getting stored in your phone. Your data, when you're typing something and clicking send, it's actually going to it's not directly going to the person who is receiving it. It's actually going to a cloud store where that data is getting stored. From there, it's getting routed to a person who is the recipient. So all of your data, and that's when you go back and on your archive and see your data, you're actually invoking the cloud god to see, show me my data. What did I chat 10 days back? It is not on your phone. That WhatsApp chat, when you are going back and seeing 1 month back, what did I say? It's actually connecting back with the server and collecting that from the cloud. So big companies like Google has its own cloud called Google GCP, it's called, right? Google Cloud Platform. Then Microsoft has got something called Azure, AZURE. Amazon also has a big cloud platform called AWS.
AWS.
Yes, absolutely, right? So these are all, you can read more about it. These are all, and then there are many other cloud, small and medium-sized cloud providers. These are all the large cloud platforms which help us and businesses with storing this huge amount of big data that we are talking about every day. That huge amount of data. We talked about the data explosion. Somewhere you need to store. It used to be so much more expensive earlier. Now it has become a lot more cost-effective and inexpensive to store data, but it's still expensive if you're talking about the, like, for example, Chat GPT I talked about, right? Where you can ask questions. Chat GPT is actually an example where the system was trained with a huge amount of unstructured data, like articles, video, articles and text and data and numbers, all kinds of things from the internet, Wikipedia data, for example, all of that. 175 billion variables were used to train this data. And that's called a large language model. Now, running this large language model is not very easy. So to run so if you want to really run, OpenAI, the company that is running ChatGPT, their daily running cost is upward of $100,000, which is like 80 lakh rupees. The company that is running ChatGPT, their daily running cost is 80 lakh rupees. Just imagine. You are only just typing a question in ChatGPT. Many of us are using ChatGPT. You said yes. But imagine the cost behind it. Of course, they are not doing it for charity. Companies are using that to integrate with their systems, and there's a revenue source for them. What you are using is a free source that we are getting, but there is a clear business model around it. And then there are other companies. Microsoft has its own version, a lot of things. So this is a huge business when you're talking about this large cloud storage and getting insights out of that. Let's come back to it. So we talked about gathering the data. We talked about cleaning the data. Once you do that, next thing what you need to do is, all data is in place. You are good to go. Now you need to write programs to analyze data. Important thing you need to understand here is, analyzing data is not just about some technical skills. You need to first of all figure out, what do I need to analyze? If you ask 5 people in a company, what do you need to analyze? They will give you 5 different answers. If you really want to be a very powerful data analyst or a data scientist, you need to have that ability to solve problems. Somebody will say something, somebody else will say something. You need to make sense out of all of that, ask the right questions, and then then figure out what is the question I'm really trying to answer. What does the company want? Are we trying to answer questions like why are sales declining in North India for this particular product? Or is it a deeper question? Right? Between these two products, where should I focus my energy on in terms of sales? These are two different questions. Data might be same, but depending on what question you ask, and then you start writing your programs to really get that an insight, your answers will be different. So finding the right problem is extremely important in data analytics. Then that is not even about Python or any data programming language or the big data skills I talked about. So I'll come to what languages and all that little bit, but third part is an analysis. You are analyzing the data. That's the real analytics that's happening there. You're trying to find out the insights. Now you got a lot of insights in tables. If you present that to the head of a department or a CEO of a company, that person will get confused. You are showing a large spreadsheet and saying, this is my analysis. Last leg of this is how can you present it? Can you have nice charts and graphs? Can you really remove a lot of unwanted insights and really focus on the issue that the CEO is really looking at? So the fourth part of it is how you are presenting it. That's an extremely important part of this also, which is your reporting. How are you going to report that? And there are tools. For example, there's a tool called Power BI, which will help you with that. You don't even need that. Sometimes it can be just a PowerPoint slides you make with the charts. But you need to figure out a way how you can present that. Even Excel, you can make charts out of that and present that Excel. But if you give a dump of analysis on a spreadsheet data in Excel, that's not going to really help a lot of people. You need to figure out. And telling, sometimes I have seen presentations where people are so much eager to give insights. There's a 100-slide deck with lots of insights. Only I get a headache after that, right? Because 100 slides and you are lost. What is it that you're trying to tell? So you have to also figure out what you need to eliminate. Not tell everything that you want to tell, because data will tell you lots of stories. See, it's like a movie editor, right? So, for a 2-hour movie that you're watching, while they're shooting, I'm not talking about retakes and all. They'll probably take about 6-7 hours of video. There'll be big scenes that you will not see in your final movie. A movie editor's job is very important. That person, he or she, will have to actually cut out a lot of things, even if it looks like really good scene. This is blocking my storytelling and this is making more complex. Ruthlessly chop it off. So a good editor will chop it off and compress that 6 hours. And that's why some movies are feeling so bulky, because the editor hasn't done a good job. We don't need that scene. Similarly, we don't need that slide. We don't need that insight. Come to the insight on a slide or on a report, which you really need. So presentation skills are extremely important also when you want to become a good data analytics professional. So can someone recollect the stages, or let's go through it once together? What is the very first stage?
So collecting the raw data.
Collecting the raw data. It can come from anywhere, from survey, from articles, from social media, from your reports, spreadsheets, wherever. Second?
Cleaning. Processing the data.
Processing the data. Yes. Cleaning the data, because it's coming from a lot of different places. And data processing, that's a good word, right? And you manage the data so that it's all making sense. Your data is all stacked up. So I have some books here. So if all these books are like here and there, right? Then when I'm looking for a novel to read, I'll find it difficult to figure out. But if I'm putting novel where it should be, it's much easier for me. And the textbook should be in another place. It'll be easier for me to figure out, right? So all of that is processing the data and organizing it. Then third?
Cleaning the data.
Analyzing the data.
Analyzing, cleaning is done, then analyzing the data, which is where you are using programming languages to really analyze that data. Then once you analyze and interpret the data, you get insights. Then what do you need to do? The last leg?
Reporting.
Present the data.
Present it.
Present the data.
Present the data. Yes. Present, you report it, you show graphs and charts and you write some words, 3 bullet points on what is the data really telling.
Data representation.
Data representation, absolutely. It is as simple as that. So data analytics might look like a very complex term, but if you understand this, then your basics is in place. Now we need to figure out what are the kind of skills I need to get, right? Gathering the data, let us park that, because that is less of a data analytics problem, which is the starting point. You can conduct, there are surveys and all that. big data and data cleaning, analysis, all of that. There's a term that I'll just introduce that term. I'll not go into a lot of detail. This term that you will see called ETL, which means extraction. You are extracting the data, then you're transforming the data. You're converting that, like which novel should go into which shelf, for example. And then you decide that, keep it all on your shelf. Then you have the real shelf. You load it there, the books there. So that's called loading. Extraction. So you have a heap of books kept there. Then transformation, I keep it on my table. Okay, novels are here, the textbooks are here and all that. Then I finally have my shelf here. I load it onto that. So that's the loading process. Extraction, transformation, and loading, ETL, right? And there are lots of, so Hadoop, Apache Hadoop is an open source tool, which essentially it came up with this whole framework of how to analyze big data. Now it has advanced a lot. The file systems that you have, HDFS file systems, Hadoop file systems, and there's a language. There's a tool called Hive, which will help you to analyze. So I'm not getting into the details of all of this. That's beyond the scope of today, and it will only just confuse you. But just hear these terms. So when you're starting to look for what kind of skills I need in data engineering, these are some of the skills that you will start hearing, like PySpark. It's on from Python. Using Python, how can you extract some of these data onto that, right? So just remember these terms. Let's not get on to the details of this today, but these are some of the terms that you'll come across when somebody is talking about big data engineering. So somebody says I have Hive skills. That doesn't mean that person has a good presentation skills or good machine learning or analytics skills. The person has good data engineering skills. How to organize the data. That's in that second part of the value chain I talked about. When it comes to the third part, we'll definitely have some time. I'm going to wind up soon, and then we'll have some time for question answers, right? So let's park the questions for that. But third part is when you are talking about analytics. The most common language that is used today is Python, right? So when I was small, again, like cloud was in the sky, Python was in a hole inside the jungle, right? So now Python is in our laptop, right? So Python is the most common language that we have today. And then there are other languages like R and all that, which are also used by data science professionals. So, or if you don't have that much of huge amount of data, you can simply use a spreadsheet also to analyze, right? You have sales data to be analyzed from 10 different places. You don't have to go into writing a Python program. Excel itself has lots of features that you can use. But if Excel says like, I give up this too much of data, or it's unstructured data, then you need to start using all of these. So there are two terms I want to introduce when you are starting to really understand, okay, there is what is this data analysis all about? One is the levels of data analysis, and then the kind of terminology that you use around it. The very basic level of data analysis is descriptive data analytics, which means you are describing. You have sales data in a large file. Now you want to make some charts and graphs, or you want to analyze that and see what product is selling where most. You're not predicting anything. You're just looking at this year's data and saying, look, boss, this is what is selling. That's called descriptive data analytics. You're just describing by analyzing the data. You can use a spreadsheet. You can use Python and all this to analyze large amount of data, but it's descriptive data analytics. Then you have more of predictive data analytics, which is you're going to predict based on all this. What is the data? What is it going to be? What is going to be the sales for the next 5 years? You have a trend. You extend that trend to see where is that going. So that will predict the sales for the next 5 years. Again, you can use Excel to kind of drag down and drop and see a trend line, or you can, for large amount of data, you can write code. I'll get in more into that, right? Machine learning, deep learning, all of that. That's the technology, the tools part of it. Even beyond that is prescriptive data analytics, where you predicted something, but you are now going to actually prescribe. This is the recommendation. This is the course of action that you need to take, which is where a little bit of a consulting hat you need to wear to say, look, data is saying this is where the trend is going. Now you need to do this. So that's the highest end of data analytics when you look at that. Okay. So descriptive, prescriptive, there are various ways. There are sometimes people put it into 3-4 buckets also, but descriptive, then prescriptive, predictive, and prescriptive. Okay.
Sir, can you repeat perspective data?
Sorry?
Prescriptive data, can you repeat?
Yeah, prescriptive data analytics, which means you have predicted a trend. Okay, next 5 years, sales is going to go up like this. So what? You ask the question, what does that mean? So then it prescribes based on 3-4 such different trends. This is what you need to do. You need to stop production of this particular product. You need to start producing more of this. That's an example of prescriptive data analytics. Clear, Nisha?
Okay, sir.
Yeah. So then, that's basically the type of data. Now, when you talk about large amount of data, when you have to analyze this using a programming, you would have heard a term called machine learning, right?
Yes, sir.
You're training the machine with a lot of data. This is part of predictive analytics. When you are training the machine with a lot of data, so last 5 years data I've trained, I've given last year's data, a year before, huge amount of data, and then created the code around it and trained the data. And now you press a button and say, what is the next 5 years data? It will predict that based on what you're taught the computer. Okay. So this is called machine learning. When you have structured data coming into this and you're trying to figure out something around it. For example, you are saying these are the number of these are the people, their professions, and the kind of products that they have bought. Now predict who will buy, what kind of people will buy products in the next 5 years based on their profession. So what you do is machine learning. I will not get into the details of that. So Python language you are using to write this machine learning code. Now there are data which you will need to use to really, which are unstructured. For example, text data, large amount of articles. You need to make sense out of it. Or social media. Like for example, during the elections, Trump versus Biden in the US, they used huge amount of social media data to predict who's going to vote for whom. And even they modified their campaigns based on that to actually influence people's behavior. Now there's a question of ethics also there on that, whether you can do that or not, right? But this data is not coming in tables. It's about people's comments, people's likes, all unstructured, huge amount of data. So when you have such unstructured data, simple machine learning algorithms will not work. Then you have much more deeper ways to do this called neural networks. This is called deep learning. Again, you need a lot of time and effort to understand this. None of this is rocket science. If you have the willpower, if you want to learn it, you have the time, you have the aptitude and hunger to learn it. All of you can learn all of this. But that's called neural networks and deep learning. But I just want to introduce that term. When you have huge amount of unstructured data, you go for deep learning. What you see today in ChatGPT, the origin is in 2017-18 when Google introduced something called transformers, which is kind of a much more advanced deep learning technique. Then people worked more and more research on these transformers and encoder, decoder, all of that. And that's what has finally resulted in a new kind of intelligence in ChatGPT and the whole completing your photograph when you don't have it. All of that is coming into place because of deeper ways of doing deep learning. Okay, so these are different techniques that you use for analysis. Final layer, presentation. Simple present. I already covered this, but I'll just repeat that. Spreadsheet or PowerPoint slides, all of that you can use. Or there are tools like Power BI. There are many other tools that you can use. In fact, I talked about the cloud storage, the Google Cloud platform, Microsoft Azure, AWS. They all come with their own reporting and presentation tools also within that. You can just plug and play. So these platforms are not just giving you an empty room with a lot of space to just store your data. They're also coming up with a lot of programs and a lot of tools saying that it's like a room, but you also have a mini bar and you can open that and have a Coke if you want, right? So rather than just going out and buying or trying to create a drink yourself, you can just, it's there in the room. So all of these storage, cloud storage programs are coming with that. So at a very high level, these are the tools. And for you to be proficient, you need to understand at the bare minimum all of these tools at what that is. But then you can specialize into areas that you are most interested in. 3 things I want to say before I wind up. All of this is good technical skills, but you need to have 3 skills, which are your functional skills or business skill or workplace skill, whatever you call it. Very important for you to be successful. Number 1 is problem solving. I touched upon that a little earlier. because you need to solve the right problem. So you need to have the mindset for that. There are problem solving courses, you can find all of that. But one simple way to do this is always have the mindset to ask why. In fact, you Google and say a technique called 5 whys. So you say something like, it hasn't rained for the last 5 years in this place. Now ask a question, why hasn't it rained? Now there are some reasons you find out. Then you ask the next question, why has that happened? For example, that reason could be because there has been global temperature rise. I'm just making it up, okay, random. Then why has there been global temperature rise? Then you get into that risk. Finally, after 5 whys, you typically, or maybe it's 4 whys or 6 whys, or but 5 we are using as a thumb rule, you'll come to a place where you got to enough understanding of the problem. You don't need to ask more whys. Anything simple. When you're talking to children are great teachers. When you talk to a 5-year-old, they will always ask why. Then you answer that, right? Then they will say why that. Then again they will ask why. We were born with a problem-solving skill set. We ruined it through our education. Now it's time for you to rebuild it. Okay, so that's number one. So problem solving is very important for us to become good data analytics professionals. Second is communication. One is about making presentations, but also you need to be able to communicate. See, now I am communicating, you are communicating. So I might know a lot of things, but if I don't know how to tell that story to you in a way that you will understand, all this is a waste. Right? I'm trying my best to communicate. It has a sender, a medium, the Zoom, and a receiver, which is you. So when I'm conducting the session, I am testing my own communication skills, whether I'm able to talk. So if I'm talking to a group of CEOs on advanced or group of chief data officers who understand data analytics in a very different level, I will be talking a slightly different thing, right? So and the way I will communicate with them will not be exactly same as how I will communicate with you. If the same thing I'm doing with a set of school children, then I'll be communicating in a completely different way. So you have to adapt to your audience, and you need to communicate with that audience very well, right? So one is about good language skills, but it's also about how you can structure your thinking and how you can articulate based on what the audience wants, which is very important when you are a data analytics professional, because you have all these insights, analysis for you to go up in your career. Having good communication skills is very important. It's not just about having good English. It's not about having good accent also. I come from Kerala. I retain my Mallu accent a lot, and I don't care about it, right? It's about how you communicate it, how you are able to get across to the person what you want to say. The other person is able to understand and absorb it or not. So it's not about speaking in a very smooth talker way. That's not what I mean by communication skills. It's about communicating really your idea. Third is domain knowledge. So unless you understand the business, for example, you're trying to understand the sales pattern in a grocery store like Big Bazaar or Reliance, right? Unless you understand how the retail stores work, it'll be very difficult for you to come up with any insights, because a retail store selling dal chawal will be very different from how a Guardian will sell medicines, or a 98.4 or any of these Apollo pharmacy will sell medicines, right? So medicine is prescription driven quite often. When you go to a normal supermarket, you are actually buying things on your own volition. You want to buy it, you buy it. So you need to understand the dynamics. Otherwise, you create some Python code and then say that this is how it is, and sales of paracetamol is going to go very high because last winter it showed a surge. No, that's because last winter there was a lot of flu and doctors prescribed it. You're wrong. So have some domain understanding. Just looking at the data will not tell you everything, right? So you may not be an expert in all industries, but having a good understanding of how businesses work, read newspapers, Mint or Economic Times, one of the business newspapers. I'm not talking about page 3 of newspapers, right? Read those newspapers to have good understanding of how businesses work. How you may not understand everything. Half of it will be like, unclear. It's okay. Keep on reading online. Try to understand how the world operates. So if you have all of this, you will be a highly successful data analytics professional. I can guarantee that to you. I will stop here. We only have 12 minutes. So, I have a habit of speaking a lot. So, which is why I didn't use slides. That usually blocks me out. I'm able to communicate better when I don't have slides. Okay, so I'll stop here and then we will just get into
Continue
questions.
with the Q&A, I think so. Before going
Sir,
to
I have one question.
Yes.
I shared a question in the chat actually.
Okay.
Actually, I want to ask one
yeah,
thing.
we'll just take the quick question, then we'll go to the chat.
Yeah, hi,
Yeah.
my name is Chetan. So I'm from Bangalore, basically. So I have a question that even I sent in chat also, I'll just say what is the question is basically simply.
Right.
So I'm from a non-IT background. I'm a BCom MBA graduate with a digital marketing, PG in digital marketing. So right now I'm working as a senior executive marketing. And I joined, the reason why I joined EduBridge, the main reason was to skill upgrade and to get into IT jobs, basically. So I have a package of around 8 to 9 lakh package, what I'm getting. So if I get a job in data analytics in future, after finishing the course and the help of EduBridge or something, if I get, so will my package get decreased or increased?
Thank you, Chetan, for asking a very candid question. I know everyone will have similar questions in their head, but you articulated it nicely. So thank you for asking that question. So first of all, let me not compare with what you're doing currently. Simply the data analytics as a profession. So if you look at what I said earlier, how data has been exploding, and how data analytics market is going to explode from $41 billion last year to $346 billion in 7 years' time from now. There's huge amount of opportunity out there. We have lots of data. We have lots of business needs to figure this out because every company is competing with each other. Whoever can get these insights first and best will win. So everyone is trying to compete. That's why, so I represent EXL. We have 7,000 data analytics professionals globally. We are meeting. In fact, I just came from Pune this morning. I'm in Gurgaon, right, meeting clients. And every client wants their data to be analyzed, data to be organized. And they don't know how to do that. And there's huge amount of need for data. So we are able to kind of sell our services to those clients, right? So there's huge amount of need for this, and there aren't enough well-trained data analytics professionals. Remember the 3 things I said: domain knowledge, problem solving, and communication. Don't just focus on Python and all these skills. Have those also, because that's what is lacking with a lot of people. People on paper, they have lots of skills, but when it comes to really solving problems and communicating, they cannot. So since the demand is much more than the supply today, definitely there is going to be a significant opportunity for you to make money through your career if you do well on that. Now, marketing, communication, all of that is again extremely interesting career options. So it will be very hard for me to comment on that, Chetan. I would say one thing: whatever you do with your heart, do your best. And if you really are passionate about data and you think that that's a space where I can make, see, it should not be driven just by a CTC point of view. Let me tell you that. It has to be driven by your passion. If you're passionate about data and you really are fascinated with all these things happening and want to make your career here and be part of a very fast growing industry, then this is the place. But I know about people who have stuck on to marketing space and really made a name for themselves and had a huge surge in their career in literally few years, right? It all depends on your interest. But I can tell you that data analytics is a fantastic opportunity to go into. I hope that's helpful. There's no straight yes or no answer here, unfortunately. It really depends on the individual and the passion.
Yeah, so I can see Kritik is asking like he need what was covered in the start because he was late. No problem, Kritik. Firstly, we will be sharing you the recording, so that will be a helpful thing. Then second question is asking if I want to go into data science or data analytics domain, then how can he start with it?
Yeah. So today, so one is, of course, you need to have your basic education, your graduation and stuff like that. Then it's a question of the time, energy, resources, and that you have, which will determine how you want to get into this. On one hand, you have a certification programs, right, which you can get from a lot of different companies, right? So EduBridge will be offering some of the things, right? And there are online courses like Coursera and Udemy and all these. They also have these kind of programs. Then there would be, there are many such opportunities for you to do that. But if you really have the time investment available, then there are even MBA programs now. For example, Goa Institute of Management, IIM Calcutta, and there are many others they are all coming up with, because data analytics is such a fascinating space. Almost every other B school is now coming up with a data analytics focused program, 1-year program or 2-year programs, literally like an MBA, right? So if you want, obviously going through a program like this will definitely have you'll have campus placements, and you will get deeper into things. You'll be interacting and figuring out on real life problems. That's a different dimension altogether. But you can start with courses, online courses, right? And figure out. So how, so start with basic courses, how to become a data analytics professional. Then that will give you a bird's eye view of everything that I talked about and more into more detail. You'll have hands-on capstone projects, and you can do that. Then you can get into, okay, data engineering is really exciting me, so I'm getting into data engineering and deep diving into that. So you go more into that after that, right? So again, it all depends on the individuals, but to get a flavor of it, maybe start with an online course rather than just committing yourself to a big MBA program or a big certification. Start with a more reasonably priced basic course that gives you a good overview. Then you can equally, there's so much available even free on YouTube, right? It's a question of how you can figure this out. Data explosion also means you have so much data available at your fingertips free of cost today. So you have to put in your effort. End of the day, when we hire somebody, all we look at is whether the person knows the stuff. So you give a test, Python, data analysis. Can this person, very complex chart, can this person read this chart and try to make sense of it? Your ability to understand numbers, ability to read charts. Then you give a case study. For example, a case study like, what's the total road length in Delhi? Now, it just looks like a very random question, but that is to test whether you can actually, thrown into an unstructured problem, can you really start thinking a little bit, right? Okay, Delhi has got these radial roads like Ring Road and other things, and then there are axial roads. I'm just giving an example, right? Or maybe something else. How many cricket bats are sold in India in a year? So when you go to large consulting firms like McKinsey and BCG to hire from top premier B schools, these are the kind of questions they ask to figure out if they can think in that, right? So your thinking is also tested. So having knowledge of language and all of this is great. So having a good graduation background is helpful. But beyond that, it's what you really present is what is important. Can you communicate well? Do you know the language? Nobody will look at, okay, which course did you do and what certification you got. It has to be polished and checked and seen whether you are actually really, do you know what you're talking about? CV, if you look at all CVs look the same. Only when you just get there, you'll really know whether this person knows something or not. So try to understand the subject. Routes can be many.
Okay, so we'll just take the last question because in the context of time, we'll have then a 5 minutes quiz, then we'll end it up. Akshay is asking, what's the difference between data analyst and business analyst profession in terms of day-to-day activities? Okay, so we are asking the to-do list.
Sure, definitely. So data analyst is what I talked through in the entire session. But even one step before this, right? You are really trying to understand the business processes, how the company is functioning. All of that basically comes as business analyst. Now, the problem is very often this is a very loosely used term, business analyst. People who are doing some research, they are also called business analyst sometimes, right? So it is research, it's about processes, all of this. People who are dealing with data, they are called the data analysts. That is essentially the fundamental difference. So if you are looking at, for example, okay, there are 5 departments. They have these processes which are all running in different ways. What is common between these processes? That's a business analyst problem, not a data analyst problem. Of course, you'll need some data to figure that out, but you are thinking through as processes. You're trying to, what are the best practices in running these businesses? That's a business analyst problem. You're analyzing a business. It was a very attentive audience and very engaged audience. Thank you, everyone.
Yeah.